Okay, so now I'm going to record a video about testing the difference between two means. And now these are independent samples. These are no longer paired differences. You're talking about two different samples, and they're measuring the same thing. I mean, it could be male and female. We could do kids at Oxbow and students at Oxbow and students at Champlain Valley Union, or you could say students at CCV Winooski, students at CCV White River, and comparing two different populations to see if they have the same mean. You've got to have quantitative variables. You got to have random samples. They got to come from normal population. You can look for skew if you get the data. Usually we don't. The example I'm going to show you, we don't have the data. But it's the same as all these other significance tests we've been running. HO is always a statement of equality. You could write that as the first mean is minus the second mean is equal to 0, or you could say the two means are equal. Either works. You could say, then you're trying to say, if you don't have any idea the direction, whether one sample has a bigger mean than the other sample, they'll usually say it in the problem. And what you're looking for, the usually is there a difference, is the buzzword here. They'll say, that'll be a two-tailed test, or they'll say something about one greater than the other, and you can use a left-tailed test or a two-tailed test. Okay, well, you can do some practice to see how that works. Stack crunch, I'm sorry, this is a sheet I use for my Oxbow students, and I use stack crunch with them also. TI-84 also works, 83 also works. We're going to focus on Rossman chance, okay? So we're going to do a claim. You're going to want to state the claim. You're going to want to write your hypotheses, same process, same recipe. State the test statistic and the p-value. Make a decision. Do we reject HO or fail to reject HO? And then you want to use that flow chart to make a decision about in context. So let's see what this problem, I haven't looked at this problem yet, so let's see what it does. So we've got plant food on plant growth. We have 9, pretty small sample, isn't it? Only 9 in each group. And then they measure the heights after 8 weeks of getting the treatment. They're telling us the populations of normal distributions. Well, that's nice of them, because that means we can use these techniques even though we've got small samples. And then we've got the summary results in the table below. It says, so notice we have the two groups, the group of plants that had the plant food, and then the control group. The means is, and there's 9 in each, something they kind of embed in the text. There's n is 9 for each of these. So we've checked the conditions already. We've already said, hey, we got a normal distribution. Even though our samples are small, we have that normal distribution. We have a random sample. We're assuming there must have been some kind of random assignment, but they aren't telling us that. So that's an assumption that we don't know for sure. Yeah, so I think we're good to go. So what are the null hypothesis? Well, we're trying to see, what does this say? So what's the claim? The researcher thinks the food makes plants grow taller, so the food improves height. So to me, I think that's the claim, the food improve height. So to me, I think that if we call group 1 the plant food people, plant food receivers, that's a group population 1, and population 2, if I do mean 1 minus mean 2, that's going to be positive. So I think we have a right-tailed test. Mean 1 minus 2 is bigger than 0, so that's a right-tailed test. Okay, so that's what we're going to write for our hypotheses here. Let me come here and let's see if I can get this board to write. Let's see, let's go here and try the smart board. Here we go. So let's try this. So HO is going to be mean 1 minus mean 2 is greater than 0. You could have written mean 1 is greater than mean 2. And I'm sorry, I just messed that up. I don't hope you caught that I messed that up. This is H1. That's HO. That's supposed to be statement of equality. Let's delete that and try this all over again, huh? So HO, mu1 minus mu2 equals 0. And then we'll say for HA, now we'll use that right-tailed test. mu1 minus mu2 is greater than 0. And of course, we've got to write the claim, but let's, instead of rewriting it, let's just underline the claim. So that's my claim. So that means HA is the claim. So again, when we do our flow chart, we don't have a condition of equality. If HO had been our claim, then we would have. So let's do, so now that we've got we checked our conditions, we've got the claim, we've got our hypotheses, let's go to Rossman Chance and figure this out. So let's see here. I'll show you how to use that applet here. The formula for this is a total bear, just so you know. Let's see. Come on, get out of my way, panel. Here we go, theory-based applet. I'm going to select two means because I have two means. I don't have the data. I just have the numbers. So I've got 9 in each group. I said group 1 was the plants that received the food. So their average height was 16, and they had a standard deviation of 2.5. And then group 2 had 9. And they had an average height of 14. Boy, it doesn't seem like there's that big a difference, does there? We'll see. We'll see what happens here. So there's, I guess we can do some calculations. Shows us a little box, kind of a box plot kind of thing. There's some overlap going on. So let's do a confidence interval first. 95% confidence interval, let it calculate it. So do you see the way this confidence interval catches 0? So we're saying that the average height, we're 95% confident that the average difference in the heights, notice we're not doing the mean difference, but the average difference in the heights could be as much as the control plants could be 0.24 inches higher to as much as, oh, actually, no, did I say that wrong? Yeah, we said the plants that receive the food could be as much as 2.4 inches lower. Is it inches? Yes, lower, or as much as 4.2 inches higher. And so we'd have to write that up somehow to convey that. Probably not going to be statistically significant, but we'll see. So now let's do the significance test. We said right-tailed test. Let's undo this. Let's calculate this. And there we go. So we were okay with this. Sometimes I'll tell you, sometimes when I'm doing these, I was thinking about this wrong, and I'm gonna get like a p-value that's bigger than 0.5, and the shading will go the wrong way. So that tells me I probably thought about the claim wrong. I might want to go back and take a look at my claim again and reverse it. I made it a right-tailed test. I should make it a left-tailed test. Okay. So I'm getting, so I should report these out here. Let me get fancy here and snip those. Actually, let me do this again. Let me grab the whole thing. I wish I could get that smartboard thing out of there. Oh well. So I'm going to copy this. I'm going to put that back on the smartboard software here to this problem here. And then let's shrink that up a little bit, and then we're ready to rock and roll. So interestingly enough, even though the 95% confidence interval contains 0, now they tell me a level of significance, they do not. So since they don't give me a level of significance, I'm going to go with a 5% level of significance. And I see that my p-value is smaller than the level of significance, so I'm going to reject HO. Oh, at the 1% level of significance. Oh, I'm glad I looked. At the 1%, I'm glad I caught that. Well, since this is bigger than 1%, we're going to fail to reject HO. See how it was kind of capricious? I mean, by changing your level of significance, you can decide to reject or accept. So that's why when you're reading a report, and that's one of the things you're going to do before this course is over, you're going to go find a live report and see if the researchers report out that level of significance. We're going to fail to reject HO. And then what does that mean? Well, if we come back here, I think I still get that testing helps. Let's look at this. So I didn't have a claim of inequality. Did I reject HO? No, I didn't. So this is how I start my statement. There's not sufficient sample evidence to, oh, wait a minute. I didn't reject HO because it was 1%, right? So there's not sufficient sample evidence to support the claim that, what was the claim? Wasn't it that, that the researcher thought, let's see, the researcher thought the food makes plants grow taller. Well, the sample data doesn't support the claim that the plant food makes taller plants or something like that. Does that make sense? I hope that's okay. It's really just like another test you've been doing. It's just what the HO and H1s look like. If you want, let's do some, instead of me making this video any longer and doing another one, why don't we try posting some? I'll have a help form, like a Q&A form, and you can try some out of the text. I think this is chapter 9 of on the stacks, on the OpenStax textbook. So we can, maybe I'll post one too if I find the time. And I know you guys can sympathize with that. So, but that's how you run these tests, and I'll do one more for proportions next.